Jai Hind students, in today's lecture we will discuss trigonometry. We will touch upon only those topics and those formulas which are essential for physics. We will concentrate only on those formulas, right? And trigonometry, as we are aware, it's a branch of mathematics which deals with the study or the measurement of the three angles of a triangle. Tri means three. Agono means angle. So measurement of the three angles of a triangle. That's trigonometry for you, right? So let's start with the basic concepts in trigonometry. Students, I'm very sure you all are aware of the trigonometric functions: sine, cosine, then tangent, cotangent, secant, cosecant. So these all are the trigonometric functions. There are inverse trigonometric functions as well. But here, as I mentioned, I will be touching only on those formulas and topics which will be useful in physics, right? So in physics, we basically make use of sine or cosine functions, because sine and cosine functions are the only trigonometric functions which are of periodic nature, right? And there are certain situations where a body executes periodic motion, like the swinging of a pendulum in a pendulum clock, like the revolution of the earth around the sun, the rotation of the earth around the sun, the sighting of Halley's comet after every 78 years. So all these are the examples of periodic motion, that is, the motion of a body which repeats itself after regular interval of time. So in such a case, mathematically, in order to express or represent their displacement velocity, we make use of periodic functions. And the only periodic functions are sine function and cosine function. So we will discuss sine and cosine functions in detail along with its graphical study, right? But before that, we need to start from the very basics. So, in hexadecimal system, we consider 1 degree to be equal to 60 minutes. 1 minute is equal to 60 seconds. It's written like this, right? And you're aware, in circular system, we consider one right angle is equal to 90 degree. It is equal to pi by 2 radian. Radian is the SI unit of angle. So basically, 180 degree is equal to pi radian, or pi radian is equal to 180 degree, or 1 radian would be equal to 180 divided by pi degrees. So it is 180 divided by 3.14. It will be in degrees. So students, if you solve it, you will get 1 radian is equal to 57 degree, 17 minutes and 45 seconds. So if possible, please do remember this result. Radian, students, it is the SI unit of angle. And in the previous lecture, we have discussed or defined the radian as well. The angle subtended by an arc of a circle at its center is said to be 1 radian when the length of the arc equals the radius of the circle, isn't it? So radian is the SI unit of the angle, and 1 radian in degrees, it is 57 degree, 17 minutes and about 45 seconds. So please do remember this particular result, right? Then we are aware of quadrants and quadrant formulas, isn't it? So basically, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. You are aware all the trigonometric ratios are positive in the first quadrant. All the trigonometric ratios are positive in the first quadrant. In the second quadrant, only sine is positive. Sine and cosecant, they are positive, right? But here I am mainly concentrating on sine and cosine function, only from physics point of view. In the third quadrant, tangent and cotangent, they are positive. And in the fourth quadrant, cosine and secant, they are positive, right? So let us represent the trigonometric functions. I am only concentrating on sine and cosine function, right? And their allied angles. Let's discuss those formulas first. So what we do is, let's consider the formula for sine and cosine function in the first quadrant for the allied angles. So in the first quadrant, sine 90 minus theta, it is equal to cos theta. Sine is positive in the first quadrant. Second, cos 90 minus theta, it is equal to sine theta. 90 plus minus theta or 270 plus minus theta. There we make use of complementary function. That is, sine 90 minus theta, it will become cosine. Cos, it will become sine. Right? So in case of 90 plus minus theta or 270 plus minus theta, we make use of complementary functions. Sine and cosine are complementary functions. So this is the formula for sine and cosine in the first quadrant. In the second quadrant, only sine is positive. So sine 90 plus theta, it is plus cos theta, while cosine is negative. So cos 90 plus theta, it will be equal to minus sine theta, right? Third, sine 180 minus theta. This also falls in the second quadrant. 180, that is, the function will remain same, and since sine is positive, so it will remain sine theta. Fourth, cos 180 minus theta. Cos is negative in the second quadrant, so it will be negative. 180 means cosine will remain cosine only. So these are the four formulas of sine and cosine in the second quadrant. Students, I am again mentioning that here I am only concentrating on those formulas which will be useful in my subject, that is physics, right? The rest of the formulas you can do it in mathematics, obviously. For the non-medical students, it would be of no consequence. It won't be any difficulty for you, right? You will be studying in maths subject. So let's concentrate for the formulas in the third quadrant. Okay, over here, sine 180 plus theta. Now look, here only tan is positive and cot is positive. So sine, cos, they are negative. So it will be negative. 180 means it remains sine only. Cos 180 plus theta, it will be minus cos theta. Sine, cos, both are negative in the third quadrant. The other set of formulas in the third quadrant as well, it can be written as sine 270 minus theta. It will also fall in the third quadrant. So sine is negative and 270 means complementary function of sine is to be used. So it will be minus cos theta. Cos 270 minus theta. Again, cos being negative in the third quadrant and 270 means complementary of cosine function is to be used. So it will be minus sine theta. Is it clear? Okay, let's concentrate on the fourth quadrant then. Over here, first formula would be sine 270 plus theta. In the fourth quadrant, cos is only positive. So sine is negative. So negative. 270 means complementary of sine, that is cos. And cos 270 plus theta. In the fourth quadrant, cos is positive. So what do you get? Plus 270 means complementary of cos is sine. Other set of formulas, we can write sine 360 minus theta. 360 will get the same function, and sine is negative in the fourth quadrant, so it is minus sine theta. And cos 360 minus theta, cos is positive, and 360 will write the same function. So these are the quadrant formulas for trigonometric functions sine and cosine. Right? So students, now we will discuss the trigonometric values of sine and cos. The trigonometric values. And in terms of perpendicular, hypotenuse and base, I am very sure you all are aware of the formulas, isn't it? Suppose it's a triangle. Subtended angle theta. This is suppose base represented by B. This is perpendicular P and this is hypotenuse, the longest side. Suppose it is represented by H. Base is represented by D. Pythagoras theorem we all are aware, hypotenuse square is equal to base square plus perpendicular square. But here in terms of perpendicular base and hypotenuse, you need to remember this. Students, I hope you all are aware of Pandit Badri Prasad. Pandit Badri Prasad bole hare hare, hare hare bole Pandit Badri Prasad. So you can remember all the trigonometric ratios in this case. Pandit Badri Prasad bole hare hare, hare hare bole Pandit Badri Prasad. Isn't it? So there are 6 trigonometric functions. First one, perpendicular by hypotenuse, that is sine. Second one, base by hypotenuse, that is cosine. Perpendicular by base, that is tangent. Base by perpendicular, that is cotangent. Hypotenuse by base, that is secant. And hypotenuse by perpendicular, that is cosecant. Right? So this is how you can easily remember these trigonometric functions in terms of perpendicular base and hypotenuse. Right? Now you need to remember the trigonometric values as well. Like trigonometric values for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. This is very, very important and you must be already knowing it. Suppose for sine function, sine 0 is 0, sine 30 is half, sine 45 degree is 1 by root 2, sine 60 is root 3 by 2 and sine 90 you are aware it's 1, isn't it? And then cosine function, cos 0 is 1, cos 30 degree is root 3 by 2, cos 45 degree is 1 by root 2, cos 60 degree is half and cos 90 degree is 0. Right? You can remember the values of other trigonometric functions as well. Tan, students, its tangent is sin theta by cos theta, isn't it? Sin theta by cos theta, 0 by 1 it will be 0. 1 by 2 divided by root 3 by 2. So what do you get? 1 by root 3. 1 by root 2 divided by 1 by root 2, that is 1. Tan is sin by cos. Root 3 by 2 divided by 1 by 2. So root 3. 1 by 0, it will be infinity or undefined. Similarly, cot theta, it is reciprocal of tan theta. So cot, reciprocal of 0, it is infinity. Reciprocal of 1 by root 3, it is root 3. Reciprocal of 1 is 1. Reciprocal of root 3 is 1 by root 3. Reciprocal of infinity, that is 0. Isn't it? Similarly, you can write it for secant theta. And lastly for cosecant theta. Let's complete the chart. Okay. Secant is, students, reciprocal of cos. Right? Reciprocal of cos. Reciprocal of 1 is 1. Let's complete the chart. Okay, reciprocal of 1 is 1. Reciprocal of root 3 by 2 is 2 by root 3. Reciprocal of 1 by root 2 is root 2. Reciprocal of half is 2. Reciprocal of 0 is infinity. Simple. Just remember the basic formulas. And cosec theta, it is the reciprocal of sine theta, or so cosec theta is 1 by 0, that is infinity. 1 by 2, reciprocal of half is 2, reciprocal of 1 by root 2 is root 2, reciprocal of root 3 by 2 is 2 by root 3, reciprocal of 1 will be 1. So I hope students you will easily remember this chart, right? Well, in physics we will be making use of these two only sine and cosine functions, right? So there are some basic identities or basic formulas which you need to remember. They are, just now we have discussed, just related to sine and cosine, right? One is tan, it is sine theta divided by cos theta, right? Cot theta, it is cos theta divided by sine theta, which will be reciprocal of tan theta. Secant theta, it is reciprocal of cos theta. Cosecant theta, it is reciprocal of sine theta. Then most important one, which we will be using very frequently, it is sine square theta plus cos square theta, it is equal to 1. Right? You can easily verify all these formulas by using perpendicular base and hypotenuse concept in the case of a right angled triangle. Anyways, we will be making use of only these two related to cosine and sine function, right? Now, before we proceed further, we need to make ourselves familiar with the concept of even and odd functions, right? So here I would like to mention that sine is an odd function while cosine is an even function. So what it means is sine minus theta, it is equal to minus sine theta, while cos minus theta, it is equal to cos theta. Sine is an odd function while cosine is an even function. So if I ask you the value of sine minus 30 degree, it will be written as minus sine 30, which will be equal to minus half. And in case you are supposed to find the value of minus cos minus 30 degree, it will be cos 30, because cos is an even function and cos 30 is root 3 by 2. So that is how you need to make use of this fact. So students, remember, sine is an odd function while cosine is an even function, right? And by using this concept you can easily be able to determine its value. Now before we discuss some other formulas, we need to plot graph for sine and cosine function. And by plotting the graph, it can be easily verified that sine and cosine are the only trigonometric functions which are of periodic nature. So in order to plot the graph, we will make use of these values. So let's try to plot the graph of sine and cosine function. So what to do is, suppose this is sine function and this is cosine function. And we divide it into equal parts. These are the equal parts. Let's consider for an entire time period, isn't it? So it can be written as 0 degree, it is 90 degree, this is 180 degree, this is 270 degree, and this is 360 degree. In terms of radians, pi radian, it's equal to 180 degree. So it would be pi by 2, 90 degree. 2 pi, it will be 360. And 3 pi by 2, it will be 270 degree. Isn't it? So same over here. It is 0 degree, 90 degree, then 180 degree, then 270 degree, and then 360 degree. So let's plot the graph for the sine function. Look students, sine 0 is 0. Also remember, the value of sine and cosine, it can be only between minus 1 and plus 1. It can't be less than minus 1, it can't be greater than plus 1. So sine function or cosine function, its value lies between -1 and +1. So we'll make use of this fact. So both for sine as well as for cosine function, the value lies between -1 and +1. -1 is the minimum value, +1 will be the maximum value. So suppose this is +1, this is -1. These are the reference line, +1 and this -1. These are the reference line I've plotted, right? Let's plot the graph then. Sine 0 is 0, so this is the point. This is the first point. Sine 90 is 1. Sine 90 is 1. Now over here, in between, sine 30 is half. Now look students, 90, so we can divide it into 3 parts. This is 30 degree, this is 60 degree and this is 90 degree. Sine 30 is half. So it will be the midpoint between 0 and 1. So it will be somewhere over here. Over here. Right? Then sine 45 degree is 1 by root 2. Students, 1 by root 2 is 0.707. So sine 45 degree would lie between 30 and 60. So it will be somewhere over here. So sine 45 degree would be 0.707. Somewhere over here. Like this. Then sine 60 degree is root 3 by 2. Root 3 is 1.732 divided by 2. So it will give us about 0.85. So sine 60 degree is 0.85. Somewhere over here. 0.85. So why I am plotting these points is because to convince you that these 2 points won't lie on a straight line, because we need to include the other points as well. So it will be given by drawing a free curve. It will be like this. It will be like this. It won't be a straight line. It will be a freehand curve. Right? Now further, similarly you can get the values between 90 and 180, then 180 and 270 and 270 and 360. For 180 degree, sine 180 degree, look, let's solve it. Sine 180 degree. It is sine 90 plus 90. Isn't it? This is in the second quadrant. Sine 90 plus theta. In the second quadrant, sine is positive. So it will be plus cos 90. And cos 90 students, it's 0. Cos 90 is 0. So sine 180 is 0. So this will be the point. Between 90 and 180, again, if you plot the points, it will be a freehand curve. They won't lie on a straight line. So it will be like this. And then let's calculate the value for sine 270 degree. For sine 270 degree, it can be written as sine 180 plus 90. Students, it's the case of third quadrant. In the third quadrant, sine is negative. 180 means the same function will remain sine and sine 90. So sine 90 is 1, so it will be minus 1. So sine 270 degree is minus 1. This is minus 1. So this is the point. Again, if you consider the points between 180 degree to 270, then again all those points will not lie on a straight line. If you connect those points, it will be a curve. So it will be like this. And last, 360 degree. Sine 360 degree. It will be sine 270 plus 90. It can be written like this. Sine 270 plus 90. It's in the fourth quadrant. In the fourth quadrant, sine is negative. And 270, so it will be minus cos 90. Cos 90 is 0, so it will be 0. So it is like this. So if you continue, it will give you a curve like this. It will repeat. It will repeat. So its value will lie only between minus 1 and plus 1. So it is repeating itself after a definite interval of time. And that's the most important characteristic of sine function. It is of periodic nature. So students, in physics, whenever we come across such bodies which executes periodic motion, then mathematically their displacement, velocity, they are represented by either making use of sine function or cosine function. So that's the most important characteristics of sine and cosine function. These are the only two trigonometric functions which are of periodic nature, right? Similarly, if you plot a graph for cosine function, you can check. Cos 0 it's 1. Cos 0 it is 1. Cos 90 degree it is 0. Cos 180 degree. Cos 180 degree can be written like this. Cos 180 degree, it will be written as cos 90 plus 90. It's in the second quadrant. So in the second quadrant, it is, student, negative. So cos 90 plus theta is minus sin theta. So it is minus sin 90. So it will be minus 1. So cos 180 degree is minus 1. So this will be the point. Cos 270 degree, it will be cos 180 plus 90. Isn't it? So it will be what? Minus cos 90. Cos 90 is 0. So cos 270 degree is 0. Cos 360 degree, it can be written as cos 270 plus 90. Cos 270 plus 90. Okay, I will convince you. Cos 360 degree, it can be written as cos 270 plus 90. So it will be equal to, it's the case of fourth quadrant where cos is negative. So minus and what? Cos 270 plus 90. So that will give us minus sin 90. In fact, in the fourth quadrant cos is positive. So it will be plus sin 90. So it will be plus 1. Cos is positive in the fourth quadrant. This is the case of fourth quadrant. So cos is positive and 270 plus theta, cos 270 plus theta would give us plus sin theta. That is what I have written over here. Plus sin 90, which is 1. So cos 360 is plus 1. Cos 360 is plus 1. If you consider the value of theta in between of 0, 90, 90, 180, then if you locate those points, they won't lie on a straight line. They will lie on a curve. So if you join those points, it will give you a graph like this. Is it clear, students? And if you continue, it will be like this, same curve or same graph will repeat itself after every fixed interval of time. So students, I sincerely hope I am able to convince you the very, very essential fact that sine and cosine are the only trigonometric functions which are of periodic nature. This is the graphical representation of sine and cosine function, which is very, very and extremely important in physics. Right? So before we conclude this trigonometry, we need to make ourselves familiar with some other useful formulas. Let's discuss those trigonometric formulas as well. So, there are some other formulas. Let's discuss it. First formula is sine A plus B. It is sine A cos B plus cos A sine B. In case it is negative, then sine A minus B is sine A cos B minus cos A sine B. For cosine function, cos A plus B, it is cos A cos B minus sine A sine B. In case it is cos A minus B, then it is cos A cos B plus sine A sine B. Right? Similarly, using these formulas, what we get is sine 2A. Consider the addition sign, P is equal to A, so it will become sine 2A. So that will give you sine A plus cos A sine A, isn't it? So what we get is twice sine A cos A. You can verify this formula using the first one. Similarly, cos 2A. Okay, cos A plus A. Substitute B as A. So what do you get? Cos A cos square A, right? Minus sine A sine square A. So what you get is cos square A minus sine square A. This is the first formula. Another one is cos square A can be written as 1 minus sine square A minus sine square A. So it can be written as 1 minus 2 sine square A. That's the second formula. Right? Also, cos square A minus sine square A may be written as 1 minus cos square A. So on opening the bracket, what do you get? 2 cos square A minus 1. That's the third formula. Okay, there are still some formulas for addition and subtraction of sine and cosine function. Let's discuss those formulas as well, right? So the first formula is sine A plus sine B. It is equal to twice sine A plus B by 2 cos A minus B by 2. That's the first formula, sine A plus sine B. Second is the subtraction of two sine functions, sine A minus sine B. So it is twice cos A plus B by 2 sine A minus B by 2. Right, students? Now the third one is for cosine function, addition of cosine function, cos A plus cos B. It is equal to twice cos A plus B by 2 cos A minus B by 2. And the last one, students, fourth one, cos A minus cos B. It is equal to minus twice sine A plus B by 2 sine A minus B by 2. So students, these are the formulas, these are the trigonometric formulas which we'll be frequently making use of in physics. And as I've told you, in trigonometry this is just the tip of an iceberg. Means here I've only concentrated on those formulas which we'll be using in physics for +1 and +2 curriculum. Okay? So, this trigonometry is over. I hope you have understood this topic. And as I told you, especially for medical students who won't be dealing with this particular topic and mathematics obviously. So for them, these formulas are very, very important. They need to remember these formulas, and during several articles, derivations, these formulas will be used directly, right? So I will state once again by concluding that it is the only sine and cosine trigonometric functions which are of periodic nature. So whenever we talk about a body executing periodic motion, in such a scenario, mathematically to express its motion, to express the body executing periodic motion, we make use of sine and cosine function. So these are the graphs which we'll be using very frequently. So students, with that, let's end this session, and I hope you will continue studying well, and in the next lecture we'll continue with some other mathematical tools, right? We'll discuss about graphical study. Till then, goodbye, and do take very good care of yourself.